In Calculus 1, we learned how to do optimization problems, usually with some form of a constraint, where we tried to maximize or minimize a function and then used either the extreme value theorem, first derivative test, or second derivative test to determine if it was a max or a min. Now we want to do the same process with multiple variables. So let's suppose that I have some function f of x, y, and I'm trying to find either the maximum or the minimum value, and I'm given some constraint, which I'll make a level curve and set g of x, y equal to 0. For example, I may be trying to find the extrema of this particular function subject to every point must be on this line in 2 dimensions. So right off the bat, what we're going to do is say, let's let g of x, y be 2x plus 3y minus 6. Now I've got the constraint, and now I have two different functions of two variables. Now the Lagrange multiplier process, we're going to take the gradient of each of these functions. In this case, it would be 6x, 2y. We're going to take the gradient of the g function, which in this case would be 2, 3, and then we're going to solve the gradient of f equals lambda times the gradient of g. Lambda is a constant called the Lagrange multiplier. Our goal is not to find the value of lambda, but to use it to set up a system of equations where I can solve by just basically using the constraint and then working some algebra. You'll find 2 worked out examples on Canvas right now, so follow them, and if you have any questions, of course, email me.